These things terrify me. When I first heard that the Twitter stream would be up, I was like, this is just going to be a running heckle stream in real time. Luckily, it's proven not to be. I almost considered inviting you guys to actually roast me as we go through this, but I don't think that's a good idea. I don't know that my ego can handle that. My name is Matt Simons. I work for a company called Workiva. We are one of the sponsors here. We are a US-based company, and I work out of our Iowa office. Does anybody not from North America actually know where Iowa is? I don't believe you. The talk is terminal velocity, so doing DevOps right by removing CLIs from production environments. I hope you'll forgive me the pretension in that title, that I'm going to come here and tell you how to do DevOps right. I don't think that we have every piece of DevOps right necessarily at Workiva, but this is one piece of that kind of equation that I do feel very strongly about, and that I do believe is at least one right way to start doing DevOps, kind of one piece of that puzzle. I want to start by clarifying some definitions. So I had to kind of, that subtitle, the actual title, is a little shorter than I would prefer it to be. So I want to talk about CLIs. CLIs, if you're not familiar, command line interface. So yeah, when you SSH into a machine, terminal bash, that kind of thing. But really, what I want to talk about here is things that let you break stuff easily. So when I say CLIs, I don't necessarily mean just command line interfaces. This can be graphical interfaces, really anything that lets you as a lone actor introduce any kind of impacting change to production. So again, not just CLIs, but things that let you break stuff easily. And if you don't understand why they let you break stuff easily, we'll kind of go into that, but it should be pretty, from the number of hands that went up, I think you guys know pretty well. All right, and then production environments. So simplifying this again, or rather expanding upon it, places where breaking things is really bad. I say this because production environments, we tend to generalize, or rather specify as places that serve code to our customers, and only that, right? It's the servers that are actually serving code to our customers. But in this sense, it's anything that can even impact that, anything that depends upon it. So, for example, let's say your company uses Docker, as ours does, and you have your own internal Docker registry. If that internal Docker registry goes down, and with it takes your ability to auto-scale because your new instances have to pull images from that registry, I would consider that registry production, even though in some of the traditional senses, the strict senses, we wouldn't call it that. So expanding this out, the title that's too long to really fit in any kind of a pitch is removing things that let you break stuff easily from places where breaking things is really bad. That's kind of where we're getting to here. So when I say CLIs, if I say CLI, I really just mean any kind of interface that lets you do things on your own, kind of outside of the release process. Going to cover some recent examples, kind of case studies, if you will. The S3 outage, this should be something that I think we're all pretty familiar with. It happened fairly recently. This was the day that the hard drive from the internet was unplugged. So what happened here, real short, I highlighted some pieces. An S3 team member working on an established playbook basically made a typo, right? So this was somebody using an interface, likely a command line interface, and they made a typo, and boom. Huge problem, right? We have Azure. This was an outage, I want to say in 2014. And Azure, this was during deployment. So they basically made an incorrect switch during deployment. And again, big outage. GitLabs, you guys are probably familiar with the GitLabs thing. This happened recently as well, fairly recently. And their RCA on this was really technical, which was super cool. But if you follow it, if you go through the timeline, these were all very manual things. They were running manual commands, obviously through a CLI, over and over and over during issue remediation, during crisis, right? This was a crisis response. And then level 3, there was another large outage. Level 3 basically took out all of the voice over IP services for North America for a day. And this happened during a mistake that was made during provisioning. So why does this happen? How do we get here? Why do these things happen over and over and over again? And the answer is because basically you run arbitrary code in production. We all run arbitrary code in production. in the sense that we make changes unilaterally through these interfaces that can roll through and impact our production environments and our customers. Now, whether that be through some kind of command line interface or some other GUI that you use, essentially we all do this. And we do this in a few kind of common areas, crisis response being, I think, probably the most common one. So in our crisis response, when we're trying to solve issues, we're remoting into servers, we're connecting to databases, production databases, but also in terms of sometimes our infrastructure deployments, provisioning, those kinds of things. So we run arbitrary code in production, which is totally against everything that we normally try to do in our industry, right? All of the software release processes that we have are built specifically to stop us from doing exactly this. But those areas that I just laid out are holes in that process or in that pipeline. Story time. Okay. Long ago, eons ago, long before man roamed the earth, Workiva had a company called Rapid Response. Rapid Response was a team of about 6 engineers. And these engineers, full-time, their mission, their charter, was to basically perform crisis response. Now, one thing you need to know about our company is that we work with very sensitive data, pre-release financial data for Fortune 500 companies. Super sensitive, lots of restrictions around that, huge compliance issues. So basically, the way that we dealt with that is whenever we were having any kind of a crisis, we had a team that was specifically dedicated to crisis response. And they were able to use the tools. So they were able to log into machines, to production servers, connect to databases, do all the things, the scary things that needed to be done to resolve issues. But they were kind of by nature and by necessity very broad. Our product is huge. Our product teams are numberless. They're not, but there's a ton. And to expect any engineer to have such a broad view is not realistic. So whenever this happened, the pattern was basically the customer comes to us with a problem brought by our customer success people, and the rapid response engineers get it escalated to them, and then they have to call in the specific product team with the depth of knowledge, and basically the product team tells the engineers how to use the code to do what they're doing. It works, right? But what's really, when you kind of throw this out in a metaphor, it becomes really apparent how this is absurd. If you look at this like a hospital, this is EMTs bringing in somebody with a gunshot wound and then calling the surgeon, but the surgeon has no access to tools. The surgeon can't even talk to the patient, doesn't have any visibility of the patient. And then they call some other general practitioner to come in and use the surgical tools while on the phone with the surgeon. This is absurd. But this is where we got to. And it was a very organic process, and it seemed like it was the right way to do things, but obviously it wasn't. This is a very flawed system. But the reason we got here was because our tools were manual, because our tools were dangerous. So we had to automate ourselves out of this situation. We did. I'm going to talk to you about that. But I want to focus on the danger. The reason why we do this is, again, because the reason why we don't do this, why we're afraid of this, is because it's dangerous. I want to show you a short clip. So if you are familiar with Galaxy Quest, I hope you've seen it. It's an amazing movie. There is a point where the ship has been taken over by aliens, by baddies, and they've turned on the self-destruct sequence, and the captain has to run down and turn off the self-destruct sequence because, of course, you can't turn it off at the same place you turned it on. Why would that make sense? So I'm going to cue this up. It's about a minute long. I'm going to let the whole thing run because I love it, and it pertains very well here. Hopefully the sound works. The sound does not work. We're hooked up. We tested this earlier.
1 minute. Someone's coming.
I promise we tested this right before we started. You know what's going on?
Let's just pause it.
Yeah. Oh, we didn't change that either.
No, I think when I unplugged it, you probably just...
Oh, you unplugged it. How dare you?
Nothing to see here. There's my face.
Okay, thank you. Crisis response.
So now it should work.
Chompers? Take a left and then just straight on through the chompers.
Chompers? Well, screw that!
How are we supposed to get through this?
Hollister, do you have the sequence yet?
Okay, the sequence is 2, 2, 4, 2, 3.
What is this thing? I mean, it serves no useful purpose for there to be a bunch of choppy, crushy things in the middle of a whole thing. No, I mean, we shouldn't have to do this. It makes no logical sense. Why is it here?
Because it's on the television
Well,
show.
forget it! I'm not doing it! This episode was badly written!
Okay, Commander, now, as soon as the first crusher hits you...
Just did.
Okay, go now.
Go. Go. Stop. Go. Come on. Come on. Come on. Stop. Go. 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 Stop. Stop. Go. Stop.
Whoever wrote this episode should die!
Okay, so the reason why I love that is because everything she's saying during that whole clip is things that we have all said while running through issue remediation, while going through crisis response, right? We have these convoluted run books that there's no hope of actually following correctly, but we try, and then through the whole time we're saying, nobody should have to do this, whoever wrote this should die, right? It's bad, it's unsafe. And the reason why it's unsafe is because of single points of failure. Now, I'll promise I'm going to come back to this, but so single points of failure, we try to engineer them out of our processes, right, or out of our systems. We look at architecture diagrams. We look at trying to find single points of failure, and they're an instant flag, right? You know, you get points in an architecture review for raising your hand and going single point of failure. And side note, I love this because it's perhaps the most relatable human thing that they made single points of failure twice in the Death Star. But when we do this, when we look for single points of failure, the thing that we constantly overlook, the single point of failure that we always overlook, which sets us up for failure, is you, is me. We are the single points of failure running through the chompers. Right? One slip and it's over catastrophically. The ship blows up, everybody dies. That's what happened with S3, right? With Amazon. That's what happened during GitLabs. So these are processes that themselves don't take into account the fact that we as humans are fallible, that we are a single point of failure. And that's why any CLI, any interface that allows you as a lone actor to make any kind of change that impacts production is dangerous, is bad. I'm going to switch gears for a moment, and I want to talk about one other kind of aspect of this, another dimension, and that is scalability. So the talk before mine was amazing, and Hannah talked about how we aren't machines, right? And we are not highly available, and all of those other kind of architectural principles that we work into our systems. We also don't scale. This next set of slides is something that I've taken from a colleague of mine, Andrew Underwood, who talked about kind of CloudFormation scripts on AWS, and why they're useful to us as an organization to automate our infrastructure. Place yourselves for a moment in the role of an operations engineer on an operations team with an application developer that comes to you and says, I have requirements for infrastructure, I need something spun up. So they come to you and they say, I need a SQL database. Cool, no problem. MySQL, ticket goes into the queue, ops team picks it up and does the work, spits it back out and says, there you go, I got you a MySQL database. They do some more work on the application, they come back, they say, we've revised our requirements, now we need a cluster. Okay, we spin up a cluster. You know what, actually we need an S3 bucket as well, and we need Kinesis stream, and let's set up a trigger, and IAM permissions for everything, and now we need a Lambda and IAM permissions for that too. This is how projects evolve, right? And each one of these things is a step that requires manual human work, and it's annoying as hell, and it takes time, and people just don't scale. But take it a step further now, and we have multiple environments, right? You have a production environment, you have a staging, a pen test, sandbox, demo, all these things, and then multiply that by 1,000 teams, all of your production teams, right? This does not scale. It quickly becomes very untenable. we don't scale. Manual processes don't scale. Now this leads us to a place that's been defined as ops lock-in. So this is when your organization cannot innovate faster than your ops team will allow or is willing to support. And I think not necessarily in terms of like the emotional baggage, we're not willing to do this, but really just physically, we don't scale enough. There aren't enough of us. Our team isn't big enough. We can't do this. We are a bottleneck now. So how do we get through this? How do we get things that are safe, that are scalable, that avoid ops lock-in? Something popped into your head as soon as you saw this slide. One word, what was it? Infrastructure as code, right? Yeah. So the thing that I want to talk about here is actually more than just infrastructure as code. The concept that I want to try and float out there is that infrastructure as code is actually just a subset of something that we should be doing, which is operations as code. Operations as code encompasses everything in infrastructure as code, so provisioning, configuration, all those things as code, right? But it also means crisis response as code. The other things that we've sort of talked about, release management as code, security as code. Some of these things are things we do at Workiva. So we have amazing release management automation at Workiva. Well, and actually I wouldn't be talking about this stuff if we weren't doing some piece of pretty much all of it. But we have amazing release automation. We have security dependency scanning automation that's tied in with our release automation. These are all things that we should be doing. It's not just infrastructure as code. It's all the things as code. It's all of these manual processes that we can automate. We should, for our own sanity too. But for all the reasons we love code. We love code because code is compliant, right? We have a review process that code goes through. You have to get +1s before something can be merged. There are requirements. It's compliant. It's immutable in the sense that it goes into source control. And if we run it from source control, we know what we're getting. It's auditable. We have a trail, right? The Git history is sacred. It is repeatable. Again, we're pulling a single artifact essentially out of source control. We know what we're getting and we can run it over and over and over again. And we can run it in parallel. It's scalable. Humans are not. Everything on this list, humans are not compliant. Humans change. We don't like being audited. You probably won't do the same thing over and over again the same way unless you work on an assembly line and that's just part of your life. And I'm sorry, you're probably not here. And you don't scale. Manual processes just don't scale. The one thing this doesn't do, it doesn't let you feel like a badass. Which, if you're solving some big crisis and you are just, pounding away in terminal, jumping between servers, you can feel like a badass if you fix it all on your own and everyone thinks you're a wizard and it's super cool. But if you screw it up, you feel like a dumbass too. Code doesn't do that. What it boils down to is that code is safe. Code is not 100% safe. I think we can agree with that. We have regressions, we have bugs. All of these things sneak into production environments. But everything about our release process, the release processes that we go through, are to help try and ensure that the things that impact production are safe. It's not perfect, but it's a lot better. It's the better alternative. There are some common components. So this is where we start to get into kind of the implementation. So I've talked to you about kind of concepts so far. How do we, why do we do this? Why should we do this? There are some common components that we want to try and get to, because now the question that we have before us is, so how do we create release processes for arbitrary code? How do we create compliant processes that are safe? There are some common components. The first is that whatever your code is, it should go through source control. I'm going to go through 2 implementations that we've done at Workiva, and these are sort of the common components between them. But your arbitrary code, you should write it out ahead of time, and it should go into source control. It should go through review. It should go through some form of testing. Now, this might need to be a little bit more flexible because of how and where we're running this code. And if you can, it's amazing if you can work in sanity checking at runtime. this is just a release process, right? These are just the common pieces in any release process. All right, implementation time. We built a system at Workiva called Script Runner. We talked about naming earlier. Names should be descriptive. It's boring as hell. We could have called this Foxfire 5 or whatever, right? But it's Script Runner because it runs scripts. We started a place where we have a developer who needs to run arbitrary code in a production environment. The first step, we write out that script and we send it to GitHub. We have a specific repo where these scripts go. There are conventions, there are automated checks, and you make your pull request. We have compliance control. We named her Rosie. It's actually our release automation, but we've kind of co-opted her because she consumes GitHub webhooks and is able to run automation on our pull requests. So we co-opted her, wrote some new logic for her, and taught her how to do this. And essentially, Rosie makes sure that we have all of the repo conventions followed. She makes sure that we have the correct number of reviews and that it's the right people reviewing. And then she can send back any updates via the pull request. So she sends comments. It says, hey, you need this, you need this, you need this. Here's your checklist. So the point where our developers interact with this, their interface is essentially just Git, right? It's the interface they use all day long to write code. We then send it through a dry run. This is our testing phase. This is our automated testing phase. We've basically set up an oasis in our production environment, which is safe to run arbitrary code. And when things come into that endpoint, they are executed, but they're executed with our data layer in a read-only mode. So they're safe. We can't actually impact anything. But we can do sanity checking there. And since all of this is Python, we expect everything to come back, because this specifically is written for our App Engine environment. We expect things to come back without exceptions. This lets us know that the data that we're looking for is there, that our transformations on it are valid, all of this, and that just the code we've written is sound. Once that comes back, we check it in, and then our engineers, actually a separate set of engineers for compliance, but a separate set of engineers, basically just goes to the place where we've checked that in and just says, run this thing that has gone through this entire release process that we know is now safe. I'm going to move because I know I'm running out of time. We have also done this with our infrastructure. So we use AWS, we use CloudFormation, and so with CloudFormation, the first thing we do, we send it into GitHub, right? We make a pull request with our products to define the infrastructure for those products. And it goes to GitHub. Our release management team sends it through more release automation. The CloudFormation deployer sends that to create and update our stack definitions in AWS. Because in AWS, you can do everything via their GUI, right, as a lone actor still. So we needed some way to have an automated process to do this for us. So this creates and updates our stack definitions for us. We then, as developers, just say, hey, update it, run this, right? It's gone through a process. We have testing, again, at the pull request level. So we have business logic around what kind of IAM permissions we expect, things that we want to have attached, roles to different resources. All of that gets run through testing. But then we have runtime sanity checking using resource signals. If you're not familiar, resource signals on AWS basically say, hey, during this stack update, there are going to be checkpoints along the way. If you give me a green, I keep going. Otherwise, we roll back the entire update. We have a binary that is installed on all of our new hosts that comes up and does the business logic checking for us and says, do I see everything that I think I'm supposed to see? All the services are up that I expect to be up. Everything on me is running. I'm healthy, not just from a kind of AWS drone up down way, but from the business logic, and then it rolls through. So again, we have source control, testing, review, and sanity checking all in this package for our infrastructure as code. And we weren't really able to do sanity checking on the last one, but we did have source control, testing, and review, right? Those are the common threads throughout. So to summarize, remove things that let you break stuff easily from places where breaking things is bad. This is a huge effort, a huge concerted effort across multiple disciplines, right? This is not just infrastructure. This is crisis response. This is release management. This is security. This is all-encompassing. Anything that can roll through and break prod, you should put under a microscope and try to create a process around. I can't give you one implementation that's going to cover all of these places for you because your environments are different. Everybody's environment looks different, right? It's that we have all those common components, but it's that little 10% that's kind of different for almost all of us. So it's going to look different from you. But this is operations as code. It's crisis response as code. It's everything as code is what we're trying to get to. Don't let yourself be a single point of failure. And lastly, do it for you. The business case around this is really easy to explain, right? Businesses should buy into this because it's estimated, the Wall Street Journal said that Amazon lost $150 million around the S3 outage, right? Amazon lost $150 million around the outage. So it's real easy to say, hey, $150 million buys a hell of a lot of engineering. Let's actually build this process, right? But for you, why do you want it? Because you don't want to be running through the chompers day in and day out. Is that what you want your job to be? It's not what I want my job to be. I want to be engineering. I want to be building tools. I want to be building and maintaining the automation. I don't want to be spending my nights constantly running through, ill-kept run books trying not to step on landmines. So do it for you. That's everything that I had today. So thank you very much.
Thank you, Matthew. Who has any questions for Matthew? We still have time for a bit. Matthew, do we want to throw the thing? Do you feel confident?
I would love to throw the thing. I think you were first.
Damn.
Thank you. How long does it take to run arbitrary code on that server? And then related to that, follow-up question.
Excellent question. So probably the main concern around that crisis response as code is it responsive enough, right? What's the time lag? It's actually very quick. Because it's a separate release process that has been kind of blessed by our release management team, and everything is automated, all the steps in that are automated, basically between creating your script, getting it in, and assuming it meets all the all of the requirements, you don't have to keep iterating on it, then it's like 30 seconds. It's basically just the time of actually executing that code in production, whatever amount of time that would take. It takes that long.
Cool. That's fast. Do you also use that to do research? Because a lot of times you don't know yet what is the problem, and just fiddling around. What does the network do? I see something hanging.
Yes, we do research with it as well. So you can write a script that basically says, because there are different stages to crisis response, right? The first is kind of defining the problem. Something's wrong. What's wrong? Let's explore. So you write a script. That script is just exploratory. The output it returns is just let's go ask questions, right? And then you can change the script, update the script. The way that we have our system built, updates to the pull request itself get updated and rolled all the way through, so scripts can change. There's still an immutable history, and when we pull, the artifacts themselves are immutable. They have to go through that full, 30-second release process. But yes, we do use it for finding, exploring as well.
Cool. Thanks.
Yeah.
Who's next? That's an easy throw.
I'm hearing things like you just said to us for a few years already. Why do you think people still not doing all that?
It's tough. It's difficult, and it's difficult to get buy-in. So when we were a team of 6 engineers whose full-time job, so that the script runner, the thing that I showed you, basically replaced all of our jobs, which is awesome. But you find yourself in a reactive place. This is common, right? Not just for operations, but for lots of places in the company. Organizations and teams find themselves in situations where they are purely reactive. We are, over our heads in water, and we're just trying to stay alive. So to be able to eke out time on the side to actually build something proactive like that, even though it's an investment that ultimately pays itself off many, many times, it can be difficult to sell that. It can be difficult to sell not just management, but even your peers who are underwater to say, hey, help me build this, let's work on this because this will help us get out of this mess. It can be difficult, and I think that's one of the reasons.
Unfortunately, that's all the time we have, but thank you again.
Yeah, thank you.